What's up, everybody? Thank you for visiting my YouTube channel. This is going to be a video on ignition and combustion systems of aircrafts. This is designed for student pilot learning. So some of these diagrams, just going to say I'll start, some of these diagrams are not technically 100% accurate, but they were made to get the general gist of how the system works for student pilots. And I'll mention which diagrams those are. So let's first start with just the main components of an engine. You have the engine casing, which is just the main metal casing of an engine. And you have cylinders. So on most trainer aircraft, Cessnas and Piper Cherokees, you're going to have 4 cylinders. So you have 2 on each side. Then you're going to have 2 magnetos, which sit at the front of the engine. So the pilot would be back here. Propeller is going to be up here. And then you have wires coming off each magneto. So you have right magneto wires and left magneto wires. And there's 4 per magneto. And they end at these spark plugs, which there's some on the top, and then there's also some on the bottom of each cylinder. Okay, so let's switch over to this diagram, which is a little bit more simplified. It's going to show the left magneto, the black box, and the right magneto, the other black box with the R in it, and then it's going to show the 4 cylinders. Okay, now if you look here, the blue wires are the wires coming off the left magneto here. And if you follow the blue wires, you'll see that there's 1 blue wire that gets to each of the cylinders. And then if you see the green wires coming from the right magneto, you'll see the same thing, that there's 1 green wire that gets to each of the 4 cylinders. This is because you want each cylinder to have a spark provided by each magneto. Why do we do this? The reason we have a spark from each magneto is for redundancy. So we have one on the upper part of the cylinder and one on the lower part of the cylinder. And that way, if one magneto stops working, every single cylinder still is getting a spark from the other magneto. All right, so in this diagram, these lines, again, if you're an electrical engineer or an aircraft mechanic, these are not going to be technically 100% accurate, but they're designed for the understanding of a student pilot. So you have your ignition switch here, and when you turn this switch, it's going to signal the magnetos to create a spark. So a surge of energy will come through all these wires and into each of the cylinders from the magnetos when you turn the ignition switch to start. At the same time you turn the ignition switch to start, it's signaling the battery to power the starter. Okay, so when you turn the ignition switch, the key points to remember here, you're telling the magnetos to provide a spark and you're telling the battery to power the starter. So how does the starter work? Well, here we have a zoomed in photo of the starter. So again, as you turn the switch, the magnetos provide a spark and the battery powers the starter. So here is our starter. The starter, with power from the battery, is going to spin the small red gear here. This red gear is connected to a larger gear called the flywheel. So as the starter gets power from the battery, it spins a small gear, which spins a big flywheel, and this flywheel is connected to the propeller shaft and causes the propeller to start rotating. So when you start an aircraft, if you notice that the propeller will start to rotate slowly, this is why. Okay, so let's take a look at what's happening inside the cylinders themselves. Now this image here is an inside view of 2 of the cylinders. In this particular image, we have what we call a horizontally opposed engine. This is what you'll find in most trainer aircraft like a Cessna Skyhawk or a Cherokee Warrior. And what this means is that as one piston moves in and compresses the air, the other piston is moving out and expanding the air, and vice versa. So how does this happen? So we had our starter being powered by a battery, spinning a small gear which spun our flywheel, and our flywheel is spinning our propeller shaft. So our propeller shaft is right here in the middle of this diagram. And as our propeller shaft spins, our crankshaft and crank rod, which are connected to the shaft, are converting this rotational energy into translational energy left and right. So as the propeller shaft spins, the crankshaft and crank rod make our pistons move in As one goes in, the other goes out, and then as you continue to spin, then the other one will go in while the other one goes out, and the process continues. So as we get compression, we have our magnetos providing us sparks into a spark plug on top and bottom of the cylinder. So if it's timed right and you get a good mixture of fuel and air inside your chamber, and you get good compression at the same time you're getting sparks, you will have combustion. Once you have combustion, your propeller shaft is going to spin much faster than when it was powered by the battery, starter, and flywheel. This is because the force of combustion is much more powerful. This is because the force of combustion is much more powerful than the power coming from the battery and the starter. And what's happening is, as you get combustion inside this chamber, it's going to want to push the cylinder back out. As this cylinder is pushed out, this cylinder is being compressed, and then the process reverses. You'll get combustion that will push this cylinder back out and compress this cylinder. And if you continually get sparks, combustion, and this process continues, now the process is reversed and the energy is going to be changed from this translational energy into rotational energy of the propeller. So when you're starting the engine, the propeller is going to spin slowly because it's being powered by the battery and the starter, but once you get combustion, the propeller is going to spin violently, very quickly, because that combustion is now what's powering your propeller shaft and not the battery anymore. So I hope this made sense for everybody. Please follow me on Instagram at @part_time_pilot, and please stay tuned for more videos. My next video is going to be on electrical systems. I hope everyone has a fantastic day.